Hello everyone. In this video we will see the next problem, which is product of array except self. So this is and we have three methods. We will go through each method and discuss each method. So given an integer array, so we have given an integer array nums and written the an array answer such that answer of I in answer array it, answer of I is equal to the product of all the elements of the nums except nums of I. So the value at index I would be product of all the elements except that index. For example, here except 0th index, the product of these three index values would be 24, and the value except this value 2 into 4 12 into 1 12, so that will be stored at index 2. So except that number, the product of all the other numbers we have to store. So the product of any prefix or suffix of a numbers is guaranteed to fit in 32-bit integer. So the product of prefix, so prefix is, for example, if we are considering this element, then the product of prefix are the left of this that element, and the right side product of right side element will be the suffix product. So you must write an algorithm that runs in order of n time without using the division operation. So we can easily come up with order of n square, which is for each at each index we are multiplying the all the values at other indexes except that particular index. For example, here at 1 multiplying all these three will get 24, at 2 multiplying all these the remaining except in value at index 0 index 1, we get this by order of n square, but it is asked us to solve in order of n time. So we have to solve by n time. Even if we can solve in order of n time, with division we can easily solve. For example, in initially we will multiply all the numbers. For example, here we get 24, then we will again create a one answer array by iterating 4 times. For example, initially by iterating through these numbers, initially what we do is we divide 24 with 1, divide 24 with 2, we get 12, 24 with 3 we get 8, 24 with 4 we get 6. So that is one more solution which we can solve you in order of n time, but that is using division operation, but it is asked us to without asked us to solve without division. So these are the conditions. So the nums length would be between 2 to 110 power 5, and the value in nums would be minus 30 to 30, and the product of any prefix or suffix nums is guaranteed to fit in 32-bit integers, like above it's mentioned. And also one more thing to note about here is using division there is a one drawback also, where if there are value with 0 elements, then in that case it become we can't divide with 0. So that is also one drawback with division. Maybe that is the reason they have asked us, that is the reason they may have asked us to find out the program without division. So let's see the other three solutions. uh, First go through our first solution, which is here we have solved here using order of n space. Order we have used extra order of n space. And so first in first method what we are doing is we initially get the nums array, and here is the nums array, and what we do is initially we create this we take the length of the nums, which is here 4, and Then we create two arrays for storing two arrays. One is prefix and suffix. One we created for storing prefix sum, and one more is for suffix sum. So the logic here is, initially we create two arrays. In each if the element in array would be like, what we do is, initially we have this given array. So in first first array, which is prefix array, what we do is, in each at each index, what we store is the sum of left of that particular element. For example, here some like product of the not some product sorry it's product of, so product of the left of that element. So product of left of that elements is nothing, so here that is the reason we take 1. The product of left of these two is 1, so 1. Product of left of 3 is 2 into 1 is 2, and product of left of 4 is 3 into 2 into 1 is 6, so 6. And in the prefix array, uh, we store the right side. So this is prefix, and this is prefix, and this is suffix. So in suffix array, what we store right side products. For example, at index 0 we store right side product, which is 24, and at this index right side product are 3 into 4, which is 12, and at this place 4 and 1. So we get this one, and later if we product these two, we'll get the our answer here. 1 into 24 is 24, 1 into 12 is 12, and 2 into 4 is 8, and 6 into 1 is 1. So that's how we get the answer. This is the logic we are going to follow in each of these steps. So we will see the first step, how it is going working. Initially we have created the prefix array and the suffix array with the default values as 1, and then later we are iterating through one while loop, where initially we take the I is equal to 1, and it will run till the end of the array, so till I less than n. So initially prefix of I, we start from index, we have started from index 1 because I is 1. We start from here, prefix of I equal to prefix of I minus 1, which is I minus 1 into nums of I minus 1, which is 1. So we product the previous in prefix into the previous to this index from nums, so that we get 1. And same way for suffix, what we do is we do this in reverse order. So we get in suffix, we take the last element. So yeah, we'll take last element, and uh, here n minus I is 4 minus 1 is 3. 3 suffix of 3 is 1, and 1 into nums of n minus 3, n minus 1 is 3, nums of 3 is 4, so 1 into 4 is 4, so here we get 4. So that's how here we get 1, and this is here we get 4. And then next we I becomes 2, and 2 is less than 4, yes, and prefix of I again. Prefix of I is equal to prefix of I minus 1 into nums of I minus 1, which is 2 into 1, which is 2. And same way here, suffix of n minus 1 minus I, which is n minus 1 is 3, and 3 minus 1 is 2. So sorry, n minus 1 is n is 4, 3 minus, so 2, now I is 2, right? 2, 3 minus 2 is 1, so num suffix of 1 equal to suffix of n minus only n minus I, which is 4 minus 2 is 2, so this into, which is 4 into nums of n minus I, which is 3. 4 into 3 is 12, so we store 12 here, and I plus or I plus plus, and again we come here, I becomes 3, and prefix of I equal to prefix of I minus 1, which is 2 into 3, nums of I minus 1. 2 into 3 is 6, and here nums of yeah, suffix of n minus 1 minus I, which is this index 0, is equal to this element, which is n minus I 12 into 2, which is 24. We get this, and later we will create one answer array with default zeros, and then later we will run one more for loop where we add the each elements at, at indexes and store it in our answer array. So here at index I 0, we add the index value at index 0 in prefix and suffix, and value at prefix and suffix at index 1. We add 1 1 12 12 2 4 we will not be adding, we will be doing multiplication. So 2 into 4 is 8, and 6 into 1 is 6. So that's how we get our answer. So here as you can see here, the time complexities, here we have used one array, one loop which goes till which iterates till the size of array. So that is the reason this is n and this is n. So there are two n's, two order of 2n, so the highest term we take. So that is the reason the time complexity of this program is order of n, and the space complexity is order of again this is also order of 3n actually, n. So the highest term is n, so that is the reason space complexity is order of n. So yeah, this is our solution, first solution. Let's go to our second solution. So in second solution, the logic is same, but we will not be using these two extra arrays. We'll be using only our answer array. So initially we create the we get the nums, and initially we create the answer array, which answer array with the default values 1, and we iterate through our given array, where answer of I equal to answer of I minus 1. Initially it start from 1 here, answer of I minus 1 into nums of I minus 1, which is answer of I is 1, is equal to answer of I minus 1, which is 1, into nums of 1 I minus 1, which is 1. 1 into 1 is 1, same way as here what we have did. And next iteration, answer of I equal to answer of I minus 1, which is 1. 1 into nums of I minus 1, which is 2. 1 into 2 is 2. 2, and again in next iteration, one answer of 2 into 3, which is 6. So we are doing the same thing here, like here we got 1 2 6, and also here also we got 1 2 6. And then in next iteration what we are doing is we are following this. In first iteration we have followed this, and this logic we have executed this and stored in our answer array. And in next iteration we'll be following this next statement, which is we'll what we'll do is initially suffix value will be 1, and initially suffix value is 1. If we iterate again through 0 to this time 0 through n minus 1. So we'll start from here. Initially what suffix into nums of I 1 minus I, which is I is 1, I is 0, n minus 1 is 4. N minus 1 is what's say n minus 1, n minus nums of n suffix. Okay, suffix of 1, suffix of, yeah, initially suffix will be 1, and in suffix we get n minus 1 minus I is 0, n minus 1 is becomes 3, so value at 3 is 4, so suffix becomes 4, and suffix into answer of n minus 2 minus I, which is no, 4 minus 2 minus 0, which is 2. N answer of 2 is 3, so 3 into 4 is 6. So that's what we store in n minus 2 minus I, which is in this place we store 6. So in next iteration again suffix becomes 12, because 4 into nums of n minus 1 minus I, which is 3. So 4 into 3 is 12, and in answer n minus 2 minus I, which is 1. So 4 minus 3 is 1. So in answer of n minus 2 minus I, we store suffix of which is 12 into 12 into answer of n minus 2 minus I, which is which was 2. So that is what we are going like here in suffix we will be like before getting 12, in suffix we will be having 4, and in answer of n minus 2 minus I we will be having 2, and what we are doing is answer of n minus 2 minus I, we are storing answer of n minus 2 minus I. So we got 4 into 2 becomes 8, and then in next iteration when I becomes 3, 0 is covered, 1 is covered, 2, yeah, I becomes 2, and nums of which is 4 minus 1 minus 2, which is 1, nums of 1 is 1, we have 1 here, 1. So here in suffix we get 24 into 1 is 1. I think I have written this suffix wrongly, but yeah, just we will take once again suffix. I think something is wrong I have written here. So initially we have we will come from initially we have 1, and so in suffix we have 1 and index is 0, nums of n minus 1 and minus 0, which is 3. 3 at 3 we have 4, so suffix of 1 into 4 becomes 4, and then suffix into nums of n minus 2 minus 1, which is 4 minus 2 is 2, 2 minus 0 is 2. So here what we are storing is suffix which is 4 into suffix into n minus 2 minus I. We had 2, so 4 into 2 is 8, and next what it becomes is I becomes 1, and nums of 1 is what we have, nums of 1 is 2, so 4 into yeah, at 2 we have 3, so 4 into 3 4 into, yeah, this is correct, 4 into 3 is 12, and we here we get nums of n minus 2 is 2, 2 minus 1 I is 1, so 1, nums of 1, answer of 1 is initially 1, 1 into 12 equal to 12, and next I becomes 2, nums of this is minus 1 minus 2, which is 1, nums of 1 is 2, so 12 into 2 is 24, and answer of 2 which is 0. Initially we have 1 into suffix is 24, 1 into 24 is 24. That's how we get our answer this, and we'll directly return our answer. So this is also, and this will take order of order of n time complexity, because here it is taking order of n, and again here it is taking iterating through array, so it is order of n. So order of n, 2 n plus n becomes 2n. The highest term is n, so dominant term is n, so the time complexity would be order of n. And we are here, as you can see here, we are not using arrays, just we are using answer array, so we are not using any extra arrays. So that is the reason here our time complexity is order of 1, because we are just using the constant space. You may be thinking, if we are using this answer array in question, it is asked that ignore the you can ignore the I'll just show you. Here in answer it is shown that the output array does not count as a extra space for a space complexity analysis. So we will not be considering our answer array as space complexity. So this is our second method, and we have seen time complexity as well. So let's go through our the final method, which is method 3. So method 3 is very similar to method 2, just here we have passed 2 times, we have iterated through array 2 times. So here what we are doing is, here we are avoiding the 2 times iteration. So we are using while method as we have done in first method. So this is like a combination of first method and second method. So like how we have done executed this 2 statement in one iteration, we are doing the same thing here. And also we are not using the this array, we are use extra arrays, we are using the answer array itself. So that we'll go through our solution in detail. You will get an idea. Initially we create we have we will take 2 variables, prefix suffix, and 1 and I variable, I value will be 1, and we create a array. So we create a array with default values as 1 initially, with size of n, and inside while condition we iterate this while condition till n times. So initially I is 1, so nums of 1 1 minus nums of I minus 1, which is 0, nums of 0 is 1. So 1 into 1 is 1, so we get 1. And answer of I is answer of I, which is answer of 1 equal to prefix in prefix, which is 1 into answer of I, which is 1 into 1. 1 into 1 is 1, so that's how we get here 1. And then suffix equal to suffix into suffix is 1, so 1 into nums of n minus I, which is n minus 1, 3 4, so we have value 4, so we get 4. So that is the reason here 4. And then we store in answer of n minus 1 minus I, which is I value is 1 1, so 4 minus 1 minus 1 minus 1 2, nums of 2. In nums of 2 we will be storing suffix, which is 4 into nums of already present element, answer of already present element, which is 1. So 4 into 1 is 4, and I plus plus I becomes 2. And then nums of 2 minus 1 which is nums of 2 minus 1 is 1, which is 2. Prefix 2, initially we have 1 into 2 is 2. And then answer of I, prefix, which is 2 into answer of I, which is answer of I, right? Answer of 2. In answer of 2 already we have 4, just previously we have stored, so 4 into 2 becomes 8. And then next in suffix already we have 4, and nums of n minus I, which is n minus 4 minus 2, which is 2. At index 2 we have 3, so 3 4 into 3 it becomes 12. And now here 12 into answer of already what element we have in this at this index, which is n minus 1 minus 2, which is 1. Answer of 1 we have 1, so 1 into 12, 1 into 12 is 12, so we store 12 I plus plus, which is 3. And nums of 3 minus 1 is 2, nums of 2 is 2, nums of 2 is 3. We have 3, so 2 into in prefix we already have 2, so 2 into 3 is 6. And then next here in answer of 3, answer of 3 equal to prefix already we have 6, 6 into already what element we have in answer, which is 1, 6 into 1 is 6. So and in suffix already we have 12, and 12 into nums of n minus I, which is 4 minus 4 minus 3 is 1, so nums of 1 is here you can see 2, so 12 into 2 becomes 24. And here answer of n minus 1 minus minus 3, which is 0. Answer of 0 is whatever the value present in suffix, which is 24, into whatever the value present in the current answer, which is 1. So 1 into 24 is 24. So we got our by this time we get our answer, which is 24. 24 12 8 6 is our answer, which is 24 12 8 6. So that's how we get our answer. So we here we have only iterated. It seems little difficult, but this is the very efficient from the above two, and the second method is efficient than the method one. So here we have used time complex, and we have iterated through only through array only once, so that is the reason time complexity is order of n. And the space complexity we here we just used constant variables, so that is the reason space complexity is order of 1. So that's what I have written here. So you can go through this. I have shared this solution in lead code, so I'll share the link of, I'll put this I'll put this image link, and as well as our solution link in the description of this video. Yeah, that's it. Thank you for watching.